This is the brief on improper integrals, types, and convergence tests. So, what are improper integrals? Well, they're how we use calculus to tackle problems that go on forever. You know, things like finding the area under a curve that just stretches out to infinity. It's all about handling those infinite boundaries or tricky spots where a function might blow up. Okay, first up, there are basically two main flavors. Type 1 is the one you probably think of first. It's where your integration boundary is actually infinity. Then you've got type 2. This one's a little different. It's for when the function itself goes to infinity at some specific point you're trying to integrate over. Second, the fundamental way to solve any of these is by using limits. I mean, you can't just plug infinity into a formula, right? So the trick is you replace that problem spot with a variable. Let's call it t. You solve the integral normally, and then you take the limit as t approaches that true boundary. If that limit gives you a nice solid number, the integral converges. If it shoots off to infinity, it diverges. And finally, what happens when finding the antiderivative is just a nightmare? That's where the comparison test comes in. It's a lifesaver. You just compare your complicated function to a simpler one that you already know the answer to. A classic example is the p integral, which tells us that the integral of 1 over x to the p only converges if that p is strictly greater than 1. So if your function is smaller than something that converges, yours must converge too. It's a really clever shortcut. Knowing these types and how to test for convergence either with limits or by comparison is absolutely essential for mastering integration.